So now we will discuss about the drift velocity. So as we know, in a conductor there are number of free electrons, and these free electrons are moving randomly within a conductor from one valency band to another valency band. But none of the electron is coming out from the conductor. So this is your conductor, and in this conductor there are number of free electrons. If I am drawing one of the electron and their motion, it is going here from one point to another, then it collides to the other electron, it can go like this, then it can go like this. This type of collision occurs here continuously from left to right, right to left. So this motion of the conductor electron is random. So if we are considering any of the cross section here, if we are considering any one of the cross section here, since all those electrons are randomly moving with velocity which is given as root over 3 kT by m, so net amount of electron passing from left to right side and from right to left here are equal. So net flow of charge through the cross section is 0. So there is no net current. So this we can say like that. In a conductor there are number of electrons which are moving randomly from one point to another point, in their valency band. With speed root over 3 kT by m. So if we are considering any cross section in a conductor, then number of electrons crossing right to the left, and left to right are same because of their random velocity. Or random motion. So net charge through the conductor is 0. So there is no net flow of charge, through cross section, so no net current. So this is the meaning of it. Means in normal condition there is no net current through the conductor. Now if an external electric field is applied electric field is applied across the ends of conductor. See, like this. Let this be your conductor, and here we are applying an external electric field in this direction. Due to effect of electric field, this electron experience force opposite to direction of electric field. So if an external electric field is applied across the ends of conductor, then electron experiences electrical force opposite to the direction of field, due to that force it start drifting in the direction of force. So its velocity increases. But due to random motion of other electron, this electron collide with the other electrons, its velocity decreases. So its velocity cannot increase significantly. So the average velocity achieved by all electrons, achieved by all electrons opposite direction of opposite to the direction of electric field is called drift velocity. Vd. This is the meaning of that. So the meaning of this whole statement or paragraph is that as electrons experience electric field, so in that direction it start moving or drifting, but other electrons have random motion. Due to that random motion, it collides with the other electrons. In that collision process, its velocity or decreases, then again it's move, then again collision takes place. This process continues, so it cannot achieve very high velocity. Whatever the average velocity again gained by all electrons, that is called your drift velocity. So see the mathematically how we can calculate the drift velocity. So this is the conductor. and this is kept in external electric field, and this is the electron experience force. So we can write, for a single conductor, for a single electron, F is equal to your minus E into E, and this F further we can write M dV by dt minus EE. So dV is equal to your minus EE by M into dt. Now integrate. T0, 0T means when the electric field has to be started. At that time velocity or VRMS, and that is called random velocity. As T is T, that velocity or V. So our equation will be like that. V minus VRMS is your minus EE by M into T. This is the equation for your electron, single electron. But if we are considering all electrons, on considering all electrons, so all electrons means their random velocity for all electrons will be 0. So VRMS for all will be here 0. And now in T is equal to your tau, V is equal to your, we can say, Vt. So then the expression written as Vd is equal to your minus E tau by M into E. So this Vd is called your drift velocity. This Vd is called drift velocity. So the meaning is that now all conductor here, so it can be taken as like this. So in the conductor it can be taken as when we are applying external electric field E in this direction, so all electrons have a constant average velocity in the same direction, Vd like this. So now if electrons are moving in that side, so current direction is this. So if n is the number of electrons per unit volume, and S is the cross-sectional area of conductor, then current is given as, current I is NES Vd. This is the relation for current between drift velocity. So now this further we can write here, and in this here tau is nothing, tau is called here relaxation time. It is the time between two successive collision. It is the time between two successive collision, and this tau further we can define as tau is your lambda by VRMS, where lambda is called is mean free path length. It is the distance between two successive collision. two successive collision. So this is the meaning of this your tau as well as lambda.